Okay, the image sensor must be able to capture the image.
It does.
The image sensor must be able to perform in a variety of light intensities and directions, including overcast weather, dusk, dawn, visibility, midday brightness levels. How did you do testing for that?
So there's a number of different automatic adjustments inside the library that we went through that would allow us to test it under various conditions. And so we tried out different specifications for the camera under different lighting conditions.
The image sensor must draw a small amount of power relative to other image sensors on the market, which is 50 microamps, and standby and 100 milliwatts in active mode on average.
So it's higher than that because we had to swap out the image sensor that we were using, but it still remains low relative to other sensors on the market.
And do you know what approximately it is?
So typically the image said it's about 300 to 400 milliamps, and ours operates around 200 milliamps.
The lens the lens responsible for image acquisition must have a field of view that creates a consistent image size across the various positionings that the modules will have relative to image subjects.
And it does.
The processor must be able to acquire images from the sensor and perform CV algorithms on the acquired images.
It does.
The processor must draw a relatively small amount of power, which is 140 milliamps on average, while performing CV algorithms.
And it does.
The trail nodes must communicate on a band that is allowable by the FCC.
Yes, the XBs run on the 900 megahertz band, which is allowable for scientific stuff.
The trail nodes must have a range of at least 3 miles.
We are not sure about that with the current radios that we have. Potentially, the XBs will produce that range, and we think that we just need higher power, higher gain antennas, but the antennas that we use for testing were chosen due to cost.
So
And
they
so
are
what do you-
operating due to spec for urban setting.
Okay.
We did get about 100 yards of range right on campus.
Off campus, we should get a lot longer ranges where the trail is.
The area has to be clear of any large buildings and any potential interference, but we should be able to get larger ranges.
A module must provide gateway services that will link the network to a database server.
That's the Raspberry Pi.
The cloud storage solution must have enough memory to hold all of the data set that is collected.
Plenty of space.
So how much space are you using for like a 1 day's worth of capture?
I'm not entirely sure how much it is for one day of capture, but MariaDB is very efficient, and we have like 11 gigs left on the Pi's SD card, and we're nowhere near close to being empty.
The data from the database must be accessible via a standard web browser for both mobile and desktop devices.
Yep.
The data from the database must be viewable in a variety of graphical representations.
Yep, we have the table and the fancy map.
Website access must be limited to selected user base.
Yes, you must have an account to log in.
Saw that. The trail node should enter a low power state in the evening. Do you have?
So we don't have that implemented yet due to the hardware change, but the Raspberry Pis do offer low power modes, and with the interrupts being set up, that should not be an issue.
The XBs also allow for sleep mode as well.
And the power modules are able to cut current for those sleep modes. They are
Okay.
able to interface with the peripherals and provide those services.
The trail nodes must be able to operate in the weather conditions of Rochester, New York.
And so the enclosure we designed should, be able to deal with the issues of Rochester's weather.
The module should be hidden from view when deployed in the field.
We believe that the enclosure is small enough that it should be, reasonably able to hide it.
The trails module's communication method should draw approximately 120 milliamps when active and 30 milliamps while on standby.
And it does.
Yep, the XB does that.
A sustainable energy source shall be provided to each trail module. We saw the wind belt demonstration. Although that's a trickle charger for a battery that does have to be replaced or recharged or something.
Yeah, there is a, the nodes are not indefinitely deployable. There is a length of time, but like I said, we were just trying to mitigate the rapidity with which we had to swap out the batteries with the wind belt.
Modules, we use a wireless mesh protocol. I think we got that.
That's
Yep.
built into the XBs.
The server that hosts the data must be secure to prevent any unauthorized access.
Yep, we had 2 security majors come in and try and hack us, and they couldn't.
Mesh protocol must have encryption services.
That's built into the XPs.
Server must have an uptime of 95%. This means protection from DDoS and similar attacks must be built in.
It's been running for over like 2 months now.
Okay. With no downtime?
No downtime.
Only
No, it's
only for really quick reboots.
for just for restarts, yeah. But it's definitely, we've hit the 90 in the time that we've been, operating. We've definitely hit the 95%.
There should be a status page hosted somewhere other than where the main server is to notify the user if the server is down or if maintenance
Yep, I
is
showed
going
that.
on. Yep. The network will also be configured so that the nodes have a common operating picture.
So that did not unfortunately make it in.
Although we do have the serialization of data in place to
Yeah.
be able to communicate from XP to XP.
So the individual nodes don't have a common operating picture, but there is an Oracle view from the position of the central, both the gateway node and the CV server.
All right. 3 more. The sensor nodes should not provide an environmental threat of any nature.
As far as we can tell, we are ROHS compliant and are not, there should be no leakage, etc., from the modules.
No batteries have caught on fire yet.
Extensive battery testing has been completed. I mean, we've left batteries on for extended periods and
Nothing blew up.
with the boost converter and peripherals attached. And there is also a built-in protection circuit on the battery itself to prevent any mishaps.
Okay. And the last 2 were related to things we already saw with the website testing. So website user interface should allow an admin user to power cycle a node, and the admin should be alerted through the web interface or email if node requires maintenance.
Yep.
All right. Anything else?
Nope.